Netflix just released something that looks a lot like magic, but I'm not talking about a sci-fi movie. So current AI video editors are really good at one thing, painting over a hole. You remove an object, it patches the background behind it, and for a lot of things it works great. But kinetic events, things involving motion, gravity, collisions, that's where most tools fall apart. Imagine a line of dominoes falling. Let's say we want to see what happens if we remove the middle three. Using current editing tools, the background patches perfectly, but the dominoes after that gap keep falling anyway, like something invisible pushed them. This exposes a massive blind spot in video editing AI tools. They don't understand physics. They know what a falling domino looks like, but have no concept of why it falls. So Netflix Research built a framework that actually reasons about cause and effect before any generation begins. That framework is void, and here's how it works. The first step is choosing how to modify the scene. Say we have a scene of one person throwing a soccer ball to another. If we want to remove the catcher, we click on them, a tool isolates them, and that cutout gets handed to a vision language model, a reasoning model that acts as the director of this whole operation. The VLM figures out that the ball now needs to continue falling on a new trajectory downward, which it will eventually communicate to the next step by drawing a map called a quad mask. Most tools use a three-color system, black showing what to get rid of, white what to keep, and a vague gray zone showing where something might change. But void adds a fourth. Here, light gray marks the specific new path the ball will travel, while dark gray, or silver, marks the overlap zone, the space where the model must simultaneously remove an object and synthesize new dynamic movement in the same area. The dark gray gives the model permission to do both instead of getting confused on choosing one or the other. After receiving this map, Void, the video diffusion model, actually generates the result in a two-pass system. Pass 1 feeds the input video, quad mask, and a random noise video into the diffusion model, which is actually how these models work, iteratively removing noise until an image forms. This pass gets the physics right. The ball falls on the correct trajectory, but diffusion models struggle to maintain what a solid object looks like while it's moving somewhere it never moved in the original footage, and you can end up with a result that looks like how it feels when you try running in a dream. So there's an optional second pass. It takes the motion path from pass 1 and uses it to warp the starting noise, giving the model a fixed track for the generation so it can focus entirely on rendering a consistent solid ball. And this pass is only triggered when significant object movement is detected, which keeps the whole process computationally efficient. To train the model, researchers built various versions of reality through two simulated environments. Kubrick teaches rigid body dynamics. For example, a pair of videos will show a collision and then the counterfactual where the collision never happened. Humoto teaches human-object interactions. For example, a person holds something, gets removed, and the object responds to gravity alone. Thousands of these pairs teach the model the causal impact of removed objects, and that leads to what researchers call uncanny extrapolation, which is basically the holy grail of machine learning. One test that proved this was feeding the model a video of a person holding a helium balloon and asking it to remove the person. In the result, the balloon floated up and out of frame, which is physically correct. But the training data only ever simulated standard gravity. The model had never seen anything go up. But it worked because the VLM has read a vast portion of the internet and contains the world knowledge that helium rises. This is a masterclass in how AI is evolving. And if a video editor can deduce physical cause and effect from simulations, are we simply building better video editors, or are we on the way to a fully simulated universe?